So the first announcement that I want to make is perhaps the most important one and the most timely one. And that is that test 2 is this Friday. So you need, hold on one second. I don't mind people talk, but if you guys would whisper, it would be awesome, just because it's hard for me to track. Thanks. So test 2 this Friday, you need to have a calculator. Okay, you do need to compute like a binomial. You do need to compute the normal distribution like what we're doing today. This is partly why we have those free calculators to check out so that it doesn't pose any sort of financial burden to anybody. It is the case that no, you're not going to need to enter lists into your calculator to compute the mean or the standard deviation or anything like that, just because there's so much room there for typos when you enter lists. But you will need to do, basic computations, of course, of multiplying, adding, subtracting, dividing, and the binomial and normal distributions. Okay. So, as I mentioned, and I updated you all in the email last Thursday about all the due dates for all of these sections that we have that will be covered on the test. I will talk more about the test either tomorrow or for sure on Wednesday. It just depends on how far we get through class today, if we have time to talk about it tomorrow or whether we need to wait till Wednesday. Okay, but you should plan on coming here, being here for the full hour. Of course, if the test takes you less than an hour, you can leave when you're done. There's no reason to stay longer. And you need a calculator for sure, and optional sheet of paper with notes. Okay, I don't care what's on the sheet of paper with notes. Again, I don't collect that. But the idea behind the sheet of paper with notes is that it gives you an idea as you're making that sheet of paper, what sort of ideas you struggle with, what sort of questions you have. And so the hope is that it helps hone your studying. If you are confused on how to get to certain things in your calculator, maybe putting calculator instructions on there might be very useful. Whatever works best for you. My only rule is that you can't share a sheet of paper with notes with anybody else. Okay. Again, I'll talk more about the test, how many questions, et cetera, once we complete lesson 11. So remember, this covers lessons 6 through 11. And so next Monday, a week from today, we're going to start out with the last portion of class, and that's all on linear math. So once we finish out the week this week, we will be done with all the probability and statistics that we will be doing in the class this semester. Okay, cool. Awesome. And again, I want to recognize, I know how tired people are, how hard it is to motivate yourself at this point in the semester. I mean, I woke up this morning and I was thinking about all of you, just like how tired I am, and then, how you all must feel the exact same way. So I get it, the semesters are great, but then there's a certain point at which they kind of drag on a little bit. And we're definitely in the heart of it. For whatever it's worth, we have next week 2 days off, both of which affect our class. We have next Tuesday off and next Friday off. So that should give you a little bit of respite, is my hope. And then we have another full week, and then it's Thanksgiving. So no, we do not have the whole week off for Thanksgiving. You have off Wednesday, Thursday, and Friday. So I will be holding class on Monday and Tuesday. If you want to go home and Zoom it, You are welcome to do that if you would like. Of course, you can Zoom at any time, but I will be here Monday and Tuesday of that week. So, cool. Awesome. All right, so what I want to do is I want to pick up where I left off class on Friday. My hope is that maybe you reviewed class notes either last night or this morning, or at least somewhat recently since Friday, just because something tells me, especially given that it was the Halloween weekend, that you probably were thinking about other things over the weekend other than mathematics. So we were talking about normal distributions, and we went through the whole idea of those the interval notation, that in place of infinity, we put either 10 to the 99th power, or if we're talking about negative infinity, we put in negative 10 to the 99th power. Okay, so I kind of gave us a lot of the background scoop in order to help prepare us. The other thing that we saw is that the total area under our bell curve is equal to 1, which is so super cool, because it turns out that the probability that a data value falls in some interval underneath your normal distribution is precisely the area. Okay, but I had told you that we are going to be using a calculator to do all of these computations. So today I'm going to do a run through of how to work the calculator for the normal distribution. I did bring both versions of the calculator so that I can show everybody how to do these. Okay, so if you need a refresh, I did remember to press record, so you can refer to the recording on the box folder later. So just as a reminder, number one, you will be told when a certain situation can be modeled using a normal distribution. Okay, that's number one. Number two, in these exercises, you will be given the mean and the standard deviation. So there's really no guessing games with that. Okay, so number one, you're going to be told it's normal. And number 2 and 3, you're going to be given the mean and you're going to be given the standard deviation. Okay, it's always nice to know that sort of thing, because one of the biggest issues that people have is when you're doing homework section by section, you know, like, oh, this is the binomial section. I'm going to use the binomial to do these computations. Oh, this is the normal distribution section. I'm going to be using the normal distribution to be doing these computations. But when everything is put together on a test, you know, it's sort of harder to differentiate sometimes. So this is a nice just reminder that you will be told this. Okay, so we went through a whole bunch of things that seemed like random ideas on Friday, and my goal is to put that together today. Okay, so recall our mean is equal to our median, which is equal to our mode on a normal distribution. And we also talked about the 68, 95, 99, 7 rule being 1, 2, and 3 standard deviations from the mean. And finally, we also talked about the symmetry. So one of the things that we mentioned is if we want to find the probability that some random data value is greater than the mean, it might be too early on a Monday morning for me to ask you to tell me what this is. Does anyone remember about the normal distribution what the mean does? What's the probability that the data value is greater than the mean? 50%. Yes, thank you. Okay, we know that half of our data is greater than the mean and half of our data is less than the mean. Okay, we know these values again because it's part of the nature of a normal distribution. You want to know these things. Okay, so that whole 68, 95, 99, 7 rule, all the symmetry business that we talked about last week is really important. Now, when we're not in those nice situations, in order to compute the probabilities, we're going to need to use our calculator. Okay, and I had mentioned with your calculator, it's that normal CDF button. I will show you how to get there on each of our calculators. Okay, but essentially the key values you need to have are your lower bound, your upper bound, your mean, and your standard deviation. So what I'm going to do is I'm actually just going to start with an example in a moment. And then we'll go through a bunch of examples. Now, before I even do that, I just want to tell you on each of your calculators how you're going to find the normal distribution. And what I'll tell you first and foremost is if you know how to get to your binomial, you also know how to get to your normal. It's the same place. So if you have like a TI-83 or a TI-84 calculator, remember we have this VARS button and then in blue up above it, it says distra. So what you're going to do is hit second distra. Notice we would have, you have to scroll way down to get to the binomial. Here, we got the normal CDF right here, and we will be using this inverse norm as well soon enough. Okay, so if you have a TI-83 or 84 calculator, again, the way you get to it is you hit second VARS, and you're right there. Okay. For those of you who have this calculator that we have available for you to check out of the library for this semester, what you're going to do again is you want to get to the stat reg distra. So you're going to hit second data. And then just like you did with the binomial, you're going to cruise on over to distra. And notice we have right here normal CDF and inverse norm. Okay. So I thought I would at least start there with how to get to the buttons on the calculator. Okay. So let me start out with this. I have a ton of examples that I want to do. And I just plan to kind of run through them today, tomorrow, and then hopefully finish mid-class tomorrow. So here's my silly example. So suppose chickens on a ranch have a mean weight of 1,850 grams with a standard deviation of 150 grams. The weights of these chickens are closely approximated by a normal distribution. What we then want to do is we're going to find a bunch of probabilities. We want to find the probability that a randomly selected chicken weighs, and then we get to have fun. But I want to give you a moment to write this down. Another way to say find the probability that a randomly selected chicken weighs, we could also say find the percent of chickens that weigh whatever amount. Now, I love to draw pictures because I really get a lot out of having a visual of what it is I'm looking for. Okay, I do that precisely because if I have a picture and then I push the buttons in my calculator, I then have an idea as to whether my answer makes sense or whether I made a typo in my calculator. Okay, but I want you to notice you're told that it's a normal distribution, you're given your mean, and you're given your standard deviation. Okay, that's about the biggest hint that you can have in terms of how you're going to go about doing these computations. Okay, you ready? All right, so here we want to find the probability that, how about a randomly selected chicken weighs between 1,750 grams and 1,900 grams. Now, what I like to do when I draw my pictures is I like to put my mean right in the middle. And notice I want to find the probability that it's between about 1,750 and 1,900 grams. So that's the region that I'm finding the area of. Y'all with me? So if you have this TI-84 or 83 calculator, okay, remember what we put in is lower bound, upper bound, mean, and standard deviation. Here we want the lower bound to be 1,750. We want the upper bound to be 1,900. And then we're given the mean and the standard deviation. Now, on my particular calculator here, if I go to normal CDF, I just put it all in the parentheses with a comma in between. Some of you have a bit more high tech of these and it'll say lower, and then you're going to put in the lower bound, 1,750. Then it'll say upper and we'll put in 1,900. And then we put in our mean and our standard deviation. So rounded to 2 decimal places, we get about 38% of those chickens have weights in that region. So those of you who have these free calculators, notice if you go to normal CDF on this, the ordering's a bit different, okay? On this calculator, the first thing it asks is what is the mean? And so you're gonna put in 1,850. It says mean mu, and then beneath it, it says sigma. So with our TI-36X Pro, you're gonna put in your mean and your standard deviation first. And then you're going to hit enter, and then you put in your lower and your upper, and it asks for each of these. So here our lower is 1,750, our upper is 1,900, and now we're going to tell this calculator to compute it, and notice we get the exact same thing. Cool. Now, it was a whole different matter when I started out my teaching career 30 years ago, teaching this stuff, because we didn't have technology that did any of this. We would have to use normal distribution tables that were pre-made and that sort of thing. Anyway, enjoy technology. There are some beautiful things to it. All right, so when it's between two values, you're literally given your lower and your upper, okay? What if now I want to find the probability that a randomly selected chicken weighs more than 1,700 grams? Well, here's 1,850. That's our mean. And we want to be more than 1,700 grams. So isn't it this entire region right here? Now, why do I draw a picture? Because in the back of my head, I'm thinking to myself, it's certainly going to be more than 50%, right? Because 50% is from the mean on over to the right. Okay. So how do we do this? This goes back to when we were talking about the interval notation in class last Friday. Okay. We have our normal CDF. What's my lower bound now? 1,700. What's my upper bound? Infinity. Does anyone remember what we put for infinity? 10 to the 99. And then we put in our mean and our standard deviation. And again, if you have this calculator here, you're going to first put in your mean, standard deviation, and then your lower and your upper. So I will go here again, normal CDF. It kept my mean and my standard deviation, which is just awesome. And now for my lower bound, I put in 1,700. My upper bound, I put 10 to the 99th. And I get about 0.84. Questions there? All right. Well, we've done between two values. We've done ways more than. So as you might guess, since I like to do one of each type or more than one of each type, I'm going to do ways less than. How about 1,905 grams? So here's my mean, 1,850. Right here is 1,905. And which way am I going to shade here? To the left, because it's less than. All right, since it's less than, we have to determine what our lower and upper bound are. Well, what is our lower bound here? Negative 10 to the 99. Now, I realize a chicken is not going to weigh less than 0 grams, correct? So in the real world, it's nonsensical to put this negative 10 to the 99. However, because this is a mathematical model, you need to put in these values for negative infinity and positive infinity. I understand that it's nonsensical, like in real life, but it's because this is a model, In other words, a generalization, not perfect. And what's my upper bound? 1905, and fortunately my mean and standard deviation do not change. And so for those of you who have this kind of calculator, I'll do this one again. I go to second VARS, I go to normal CDF, and I put in, and by the way, when you're putting in a negative, my friends, don't put in a subtraction sign. Your negative sign is below your number 3 on this calculator, as well as on this calculator. So negative 10 to the 99th, and then what was it? 1905, 1850, 150, and we get about 0.64. So do you see how these are straight up calculator questions thus far? Like there's not a lot of math that we actually have to do. All right. Now I wouldn't put one, well, I'm not going to say that. What I'm going to say is you have an online homework question that does things like this. Okay. What if we want to find the probability that a randomly selected chicken weighs more than 2,100 grams or less than 1,550 grams? Okay, pictures are worth a lot here. Here's my mean, 1850. We're interested in more than 2,100, which is this region, or less than 1,550, which is this region. Notice I better use that word or because we can't be here and here at the same time. Okay, does anyone have an idea as to how we're going to do this? Beautiful. You're awesome. What we're going to do is find the area of this region, find the area of this region, and then or tells us add. That's precisely what we're going to do. So essentially, we're going to have two normal CDFs that we're going to add. Notice this region, my lower bound is negative 10 to the 99th, and my upper bound is 1,550. And then I'm going to add to that the region greater than 2,100. So my lower bound is 2,100. Then I have 10 to the 99. All right, so I can go and do second district, go down to normal CDF. Again, my mean and standard deviation have not changed. I'm just bebopping between the two calculators. So for the first one, I've got my lower bound already in there, and my upper bound is going to be 1,550. And here we get 0.02275. And now what I'm going to do is do the other interval. Now my lower bound is 2,100, and I have my upper bound already in there. So we get 0.04779. And if we add these up, we get about 0.07. So only 7% of the chickens are out there. Now, there is one other computation that we are going to be doing. But you all see now, if you're being told that it's normal distribution and you're given your mean and you're given your standard deviation and you want to find the probability, it's literally just plugging it in these things. Okay, so there's one other sort of question we can ask in here, okay? So what if there's like this really, really loud, rambunctious chicken on the ranch? And she's like, hey, I weigh in the top 10% of all of you chickens on this ranch. Now, she shouldn't be bragging because that kind of probably means she's going to be the first, one of the first ones killed, right? I know that's not very funny, but anyway. So now what I want to know is if this chicken has that sort of bragging rights, what is the minimum weight? This arrogant chicken can weigh. Okay, what I want to show you is that what we're given here is different. Notice here's my mean. And if we look at the top 10%, that's way up here. What I want to know is this cutoff value. Okay, I mean, obviously, if a chicken weighs like 10,000 grams, that's going to be in the top 10%. But what we want to know is what is that cutoff value that would place her in the top 10%. Okay, so what I want to point out to all of you before I show you how to do this computation, and I'll summarize it soon, is as follows. Notice in all of these previous examples that we did, I gave you the weights and I wanted to find the area, right? I gave you the relevant data points and I wanted you to find the area or percentage, even here and even here. Okay, now what I'm doing is the opposite. I'm giving you the area or percentage, and I want you to find the weight. You dig? Okay, so since we're going the opposite direction, what we do is we use what's called the inverse norm. It's still a calculator thing. Okay. And when you enter this into your calculator, the one key thing or trick, I'm not really sure, that you have to keep your mind on is you need to put the area to the left. And then you put in your mean and your standard deviation. Okay, so if 10% is to the right, tell me, what is the percent to the left? 90%. How'd you know that? Because it's got to add up to 100%. So here, the key values that you need to enter are the 0.9, the 1850, and the 150. Now I'll show you on each of your calculators how you would do that. If you have this TI 36, you again go to distrib, but now you go down to number 3, inverse normal. And you see, it says area. You need to put 0.9, mean, standard deviation. And so 2,042.23 grams. If you have this calculator, it's the same sort of thing. You go down to inverse norm, and I would put 0.9, 1850, and then 150. And you get the same thing. Yeah. 0.9. Okay, you always have to put the area to the left. So if this is the top 10%, we want the 90%. Okay. So I guess what I want to say is, in general, with these normal distribution problems, the main thinking that needs to happen is, if we are given our data values and want the percent or probability, you use the normal CDF function. On the other hand, if we are given the percent or probability and want the data value, you use the inverse norm. Isn't it great that you get a sheet of paper with notes so that you can not have that extra cognitive thing on you? All right. So I'm going to do, one second. Okay. I just want to say a couple more things right now about these percentages. And then what I'm going to do tomorrow are 2 more examples. And then I believe that will leave us time for me to outline your test tomorrow. Okay. Yeah. If we're in the top 10% and 10% is to the right, and you have to put in the area to the left, isn't 90% to the left? And that's where I got the 0.9. That's so cool. That's exactly what I was going to talk about. Gosh, I just think you guys are great. So what if you wanted, what if one chicken says, well, my weight places me in the bottom 20% of all of you? Well, here's 1850. Now we want the bottom 20%. And what we're looking for is this cutoff value. So kind of what's the most she can weigh to still be in the lowest 20%. Again, you still put the area to the left. So you would do inverse norm 0.2, 1850, and then 150. Does that make sense? Okay. What's another way this sort of thing can be worded? Well, what if I said, I want to know the minimum weight to place in the 95th percentile? You hear about percentiles when you're dealing with silly standardized tests. Okay. Well, what I want to mention is 95th percentile. If that's a test score, you did awesome. Okay. When you talk about the percentile, 95th percentile is equivalent to the top 5%. So that means 95% is to the left and then 5% is to the right. So if they give you the percentile, they're just telling you that you, like if you score in the 95th percentile of a test, that means that you scored at or better than 95% of the people who took the test. That's pretty rocking. Okay. So the point is if you're given the bottom percent, you're given that area to the left. If you're given the percentile, you are given the area to the left. It's just if we say the top 5% or like the top 15%, that's when you have to take 1 minus that. Does that make sense? Yeah? Ish? Okay. So what I'm going to do, well, wait, I have 2 minutes. So what if I say the bottom 12%? What's the area that you would put to the left? 0.12. What if I said the 85th percentile? Okay. 0.85 would be the area to the left. Good. What if I said the top 2%? What would be the area to the left? .98, right? Top 2%, pretend this is a picture, is 2% here, so 98% is down here. All right. So I know this seems like a lot of random stuff, but I claim we've really gotten through the bulk of things. I have just a couple more examples that I want to do tomorrow to really further clarify. Last but not least, I always have papers here. So if you actually physically hand me something, I have something to physically hand back to you if you want it back today. All right. Have an awesome day. Happy Halloween, everyone.